Vector and scalars are two different kinds of physical quantities. You can simply add vectors, scalars, by using simple algebra or arithmetic, but vectors are quite different. So, for vector addition and vector subtraction, we need some special rules. So, in this video, I am illustrating how to add vectors. So, first thing, let us begin with some uh, physical quantities that how to identify vectors. So vectors are those physical quantities that have both, that is magnitude and direction. We represent a vector by a line with arrowhead, right? If there is a magnitude, this distance gives you the magnitude, and this arrowhead gives the direction of the vector, right? If a physical quantity have only one thing, that is magnitude only but not direction, then we can call it scalar quantity. So this is the difference between scalar and vector. Right now, force. If you are talking about force, there should be some direction, right? Without direction, we cannot apply force. There should be certain direction. When you apply force, whether it will be acting downward or upward, eastward, westward, there should be some direction. So this is the vector quantity, right? And what is about speed? As we know, speed just have a magnitude, so it is a scalar quantity, right? Temperature also have magnitude only. We don't need direction. When we say 10 degrees Celsius or 10 degree Fahrenheit, we just call the number, not its direction, right? Similarly, distance is a scalar quantity, and velocity have magnitude as well as direction, so it is a vector. So I can write down vector here. And what about time? Time also just have a magnitude only, so I can write down this is a scalar, right? So what is this one? This is 20 lb up. Simply, mass is a scalar quantity, but in this question it is said that 20 lv is off, so it is a vector quantity. Okay, now let's go to another question. How to represent a vector? How can you draw a vector? As I said before, vector is represented by a line with an arrowhead, and the length of this vector gives you the magnitude, and the arrowhead gives the direction. If the length of a vector in comparison to other vector is more, it means magnitude of that vector is greater than previous one, right? So if you reverse the direction, keeping the magnitude same, this vector will not be same. Suppose that this is vector A. If you reverse the direction with same magnitude, it becomes A minus, right? So this is the vector how we draw graphically. Now in this question it is said that this is just drawing a vector given here like 200 mile per hour east. So direction is given here. You can set up a scale like, like for example 1 centimeter is equal to 20 uh, mile or something like this. You can set of any, for example you can say set of like 1 centimeter equal to 100 mile, right? If you set of 100 mile as 1 centimeter, you can draw 2 centimeter line, so that will be 200 mile per hour, right? This is velocity. So similarly, you can draw the 100 miles south. If you consider same scale, so it will be 1 centimeter, right? Draw 1 centimeter line. Similarly, you can draw this one south west. Direction is not specified. We don't know the angle, so you can simply draw like southwest, this direction, right? and 400 mile per hour, 35 degrees south of east. So 35 degree is given there. Okay, so for last one you can you have angle given 400 mile per hour, 35 degree south of east. Okay, so this degree is given here, which is 35 degree. Measure this angle and you draw this one. Okay, so it is making with positive x-axis, it is making 35 degree. Okay, so in this way you can draw vectors. Now main points is here, how to add vectors. Measure and add the vectors in each of the exercise depicted below. The vector that result from adding or subtracting two or more vectors is called the resultant. Measure the length of the resultant. So first of all, you can measure the these lengths. I will show you how to add the vectors, how to get the resultant of the vectors. Okay, my value might not be exact, you can do by yourself, but tentatively it will be very close to the actual results. So by using your ruler, just to measure this distance, how much centimeter is there, write it down here. For example, tentatively I am measuring here and it is 5 centimeter, right? And this is 2.6 centimeter. Okay, so these are the lengths of these two vectors. So first thing is how to get the resultant. We have to know that to get the resultant we have to complete the parallelogram, right? You know the parallelogram, opposite sides are parallel and equal in length, that is the parallelogram. So I'm completing this one and drawing a resultant from this point where two vectors are at the same point. It starts from the same point, right? This point. So this is called a resultant of the vector denoted by R. So this method of adding vectors is said to be parallelogram law. So from the parallelogram you don't have to derive this equation. For example, this is a vector v1 and this is vector v2, then this resultant is given by R equal to v1 square. You can directly take this equation, v2 square plus v1 v2 cos of theta. What is this theta? Theta is angle made by this resultant vector with one of the vector v1, right? So if you know this one, measure this angle, right? Suppose that I say this is around 25, or you can measure your value 25 point something or 25. So this is 25, right? You have this angle 25 degree. You have a vector, the value of the vector you already measured v1, and next vector the value of the vector v2, which is 2.6. Now you can easily get the resultant of the vector. Let me calculate this one, which is v1, which is 5 square plus 2.6 square plus 5 multiplied by 2.6 into cos of 25 degree. Okay, if you put 25 degree, if you put all these data into the calculator, you can easily get value of R, and it is uh, closer to something like 6.6 centimeter. Okay, so this is the resultant. If you look at this answer, it looks reasonable, right? If you add two vectors of values 5 and 2.6, they are pointing a different direction like this as shown in this first figure. The resultant vector should be around this value, right? This is 5 and this is 2.6. Because they are not oriented in particular direction, in same direction, they can't be added directly or they can't be subtracted. For example, for instance, suppose that vector this one, this b1 is pointing in this direction and b2 is also pointing in same direction, you can directly edit 5 plus 2.6. But you can't add vectors like the scalars if they are pointing in different direction. You can't do so. In this case, if vectors are oriented like this is b1 and this is b2, you can do that, right? But in this case you can't do that. I mean, you can't add 5 plus 2.6 equal to 7.6. It's not, right? It's not correct. This is the correct way how to add factors. This is the parallelogram law of addition of factors. Okay, I hope you understand how to add factors, and there are some other figures right here. You can try by yourselves. For example, in exercise V, these two vectors are given. Give them the name, measure them, then complete the parallelogram as I did before. Add them together by using parallelogram law of vector addition. Okay, so again I will repeat here, R, which is the resultant of the vector, two vectors, is R1. If vector is R1, before I write it like V1, it doesn't matter, just symbols, right? Plus R1 R2 cos of theta. This was the formula, right? So same approach can be applied for exercise B and exercise C. You can do that. Okay, so similarly you can draw these vectors and you can edit by using Pythagoras theorem. You can add these vectors because when vectors are perpendicular to each other, then you can simply use Pythagoras theorem. Okay, so here is the last question. Supergirl flies 200 miles east, right? This is little bit complicated, but it is not. There are more than two vectors, so it is complicated than the previous one, but you can use same approach as you did before. In this case also, you can complete the parallelogram and get the final answer. Okay, I'm just showing you some clue to solve this problem. Suppose what is the Supergirl doing here is 200 miles east. I can draw a line that is 200 miles east, right? This is the east. Then after having some rest, she flies another 100 miles north. So this is the another 100 miles, say, north. And then what she did, she stops for the night at local bed and breakfast, and the next morning runs 70 miles directly southeast. That means 70 miles somewhere here. Okay, so this is southwest, exactly measure it, right? This is making like 45-degree with this line, so measure it, and this line will be 45-degree from here or from the horizontal line. Okay, if it is horizontal line, you can draw from here. So this is her final destination, and right here this one is 70 miles southeast. Okay, so as you did before, you can use the parallelogram law. I'm just completing what I'm just showing you the method how to do it. So but you can do it, right? To complete the parallelogram, the resultant of, first find the resultant of this one and this one, right? To find the resultant, you can complete this one. That gives you, yeah, this is the even triangle law, right? You can use the this is north, this is east, so simply you can use Pythagoras theorem to find the resultant of these two vectors, right? The Pythagoras theorem, right? This r, or longest side of the triangle r, is equal to square root of the, because cos theta right here is 0, that's why this is actually the parallelogram law. Okay, 200 square plus 100 square, this gives you the value of this one, this r, right? After getting this one, as you did before, there are two vectors, this r, and give the name of this one. Suppose that this is vector a, right? This is vector r and this is vector a, and these are two vectors. You can complete the parallelogram, write down in the separate paper, so that what you can do is probably you can do like this. You can put the biggest line. Remember, the length of line should be same, right? And then this is the another line, which is 70, and this is what you get from here. This, write down value, complete the parallelogram, right? Parallelogram, and this resultant will be, measure the angle again as you did before. This is 70, this is what you get from here, and get the resultant. Okay, in this way you can find the resultant of this these three vectors. Okay.